When the man jumps off the ledge, he undergoes the acceleration due to gravity, which is a force. However, when he reaches his minimum point, or when the rope tightens, the tension caused by the rope causes him to go back up. In this experiment, we will test this out. This is the ultimate bungee jumping machine. It consists of a 90-degree arm at which at the end a mass of 1 kilogram is attached to a rubber band, which represents a spring. During this experiment, we will take the mass up to the top and drop it down. It will undergo the acceleration of gravity and pull the spring down to a certain length. In order to measure how far it goes down, I have created this makeshift measuring device, which consists of a light on the inside, which when turned on, illuminates this tube. Once the lights in the room are turned off, it will illuminate inside this tube. The weight will be inserted inside the tube, and we'll be able to see how far the weight goes down when it falls. We will be doing this experiment 3 times to make sure that we have an average for how far the weight drops when it is released.
Today I don't feel like going anywhere. No displacement from my bed. Distance traveled might be more. Pizza's here, walk to the door. But go right back to where I began.
I'm gonna kick my feet up in uniform motion, steady as I can, the velocity's constant, no motion, I'm sitting at rest.
I'll be lounging on the couch, can't go against friction, less applied force, I'm stuck at the origin, objects tend to stay at rest. Oh, he said it, 'cause Newton is the man. Today I don't feel like going anywhere. No displacement from my bed. Distance traveled might be more. Pizza's here, walk to the door. But go right back to where I began.
In doing this experiment is to find the total force that was exerted on the person. Now, as you can see, we know that the mass was 1 kilogram and the string unstretched was 6.7 inches, which we converted to 0.17018 meters. Then we did the 3 trials and averaged them out to 10.7 inches. We converted the 10.7 inches into meters by multiplying by 0.0254. So now that we figured out the initial unstretched distance and the stretched distance through the 3 trials, we are able to calculate the spring constant. To do this, we multiply 2 times mass times gravity times the initial length plus the final length divided by the final length squared. So as you can see here, we plugged in the values: 1 kilogram, 0.17018 for the initial distance, which is up here. Then we did the final distance, which is 0.2718, and then we divided by 0.27178 squared to get a K value, a spring constant value of 117.4 newtons per meter. So now to calculate the maximum force exerted on the object over this distance, we use the equation force equals the spring constant times distance. So F max equals 117.4 newtons per meter times the total, or the longest distance, which was 2.27178 meters, for a total max force of 31.9 newtons. Now that we know the total force exerted on the object, we can compare it to the weight of the object by taking the total force, which is 31.9 newtons, and dividing it by 9.81 newtons, which is equal to 1 kilogram. And you get 3.25 G's. What we have calculated is called a g-force. A g-force acceleration acts as a multiplier of weight-like forces for every unit of an object's mass, and is the cause of an object's acceleration in freefall. So in the end, we have figured out that on this system there are 31.9 newtons of force, and that gravity and tension are the two main forces at play when a bungee jumper jumps off a ledge.